Hi student, welcome back to my teaching channel, Mathematics. This is the calculus course and this lesson is continue with the lesson about limits of exponential function. And in the past, last video, I didn't have a chance to talk about logarithmic, limit of logarithmic function. So now I add into this part. And sometimes because I recorded and it losing a part, so I have to cut it at the end. Now I will continue with this. So I'm going to go over with you about the last part of the limit of exponential function, which I already wrote on the board. So I hope that you can see it. Okay, so I have to move the computer in the way you can look at it. So let's talk about this. So I have a function y equal 5 minus 2 to power of x minus 1. And I notice this function is the x here is positive, it's not negative. It means that I will not have a shape reflection going this way, but the shape of this will be this way, go this way, like normal exponential function. However, because we have a negative here, right? This is the transformation of exponential function. If you have a negative in front, this constant value, this is reflection over the x-axis. So this shape will go like this. However, it goes this way because it reflects over the x-axis, right? We know that it's normal exponential function supposed to be this way, but because it reflects over the x-axis, so now it goes this way. And you can see that this shape, that's y. So when I plug in x equals 0, I calculate the y based on this function 5 minus 2 to the power 0 minus 1. I got 5 to the minus 1 over 2. So this value is 4.5. So we have a point x equals 0, y equals 4.5, and it's right here. So by doing this, we know that the function will go through this point, and it will go down this way because the shape reflection over the x-axis. Now the horizontal asymptote, instead of right here, y equals 0, is shift up to 5 units because of this number. And that's you already learned in Math 12 about how the transformation works. So this indicates that this horizontal shift up to here. And the shape of this go through, this function go to this point. And if we plug in another point down here, we'll get 5 minus 11. So let's say if I make x equal 5, y will be equal 5 minus 2. And then 5 is substitute for x minus 1. So we have 5 minus 2 to the power 4, which is 5 minus 16, which is minus 11. And that's the point right here of the function. And by just making 2 points, I can draw or sketch the function already, right? So that is the function, and that's why it looks like this. Based on this, we can find the limit of this function as well. So if we evaluate the limit of this function, when x approaches to negative infinity, right here, right? So this is the x-axis, go this way, negative infinity. We look at the function right here. So when x approaches to negative infinity, what's the function y approach to? Function y approach to this asymptote, y equals 5. It almost 5, but it never touching 5. So it's like 4.99999, something like that, right? So that's how when we look at the graph, we know the limit of this function. So when x approach to negative infinity this way, y approach to 5. And therefore, limit of this function is 5. That's the value of it. So that's how we look at the graph and we see the limit of it. Now, let's say if you have to evaluate the exponential function for the power of x with when x approaches to positive infinity. And everybody know that as x getting positive infinity, it means this way, right? It means x become 1, 2, 3, 4, 5, getting bigger and bigger. And you have a base of 4, then the function will look like this, right? And this graph will go up forever. So therefore, the limit of this function will be positive infinity up there. And positive infinity actually is mean they're not exist because it's go up so high, reach to million, trillion, and never stop. And you don't know. So that's why it do not exist. Now, if you evaluate the same function for the power of x, when x approach to minus negative infinity, then of course, this is the basic function, right? With the base 4, then no transformation. So you know that the graph, the shape of this graph will look like this, which is will eventually touching the 0 right here, but never touch 0. So when you evaluate the limit of this exponential function, the answer is 0. Now, let's say if this base is very small, less than 1. So if you evaluate the limit of 0.9, 0.3, 0.2, whatever it is, it's less than 1. When x approach to positive infinity, so you substitute this x by positive infinity, which is a very big number. And if you can key in your calculator and try to put in 0.9 and power 10,000, 100,000 or something, then you know that this value will be equal to 0, the limit of this. So anytime you have a base, not 4, not 2, like that, it's less than 1, it's 0.0 something, right? And anytime you have a big power in here, because this base is so small, so it will, instead of going big, but it's not, it's going down, it becomes 0, very small. So let's say you evaluate limit, the next question is if you evaluate limit of x approach to 0 and the base 5 to the 1 over x, that's the power 1 over x. So then you know that if x approach to 0, if you plug it in, it seems like we have 1 over 0, no, but we know that this 0 is not actually 0, it's supposed to be 0.01. It's very close to 0, but not, right? So if you can calculate it, you know, because this problem, this fraction 1 divided by 0.01 is actually equal to 1,000. So 5 to the power 1,000, very big number. So it becomes a positive infinity. So if you evaluate the limit of this function, right? 1 over x, this function. So that's where it will happen, right? So that's how it look like when you evaluate this small base. The limit of it is 0. When you evaluate this function 5 to the power 1 over x, your answer will be positive infinity. Now, if this limit of that function, the same function 5 to the power 1 over x, but x approach to negative infinity instead. So what happened? If you have this function when the limit of x approach to negative infinity. So you substitute in there, so you will have a limit of the base 5, 1 over negative infinity, so over like negative 100,000 or something, right? So this one become very close to a 0, right? This value become, so it's like 5 to the power 0, right? So 5 to the power 0, but on the negative side, right? So the result of this will be -1. So if the act is approached to negative infinity, the answer is the limit of this -1 with the same function, but the limit of this will be equal positive infinity if it go to the opposite, positive infinity. Okay, so that's how it look like. So now let me continue to this part. I cover the last of the previous video. So now I'm going to erase this, and I will talk about the logarithmic. What is the logarithmic? What is the logarithmic? Limit of logarithmic. Let's first talk about the graph of logarithmic function first. Everybody know if you have an exponent function y equal 2 to the power of x, that's we call an exponential function. And we talk in the lecture that the logarithmic function is the inverse of this function. So its inverse is become this way. We'll write it as log. Log, the base is 2, right? So log 2 to the y, right, equal x. So that's how you write its inverse. And log 2 of y to equal x. So let's draw this one first. So we know this graph will go to number 1, right? And have a shape like this. Its inverse actually will be reflect over the y equal x. So let's say you have a y equal x. So y equal x is the line, y from here is 1, 1, 0, x is 0, y is 0. So the line equal x is like this. So it will inverse over this mirror, right? Y equal x. So any point here will reflect over here. So this 1 of y will become 1 of x. You know that the inverse function, if it's x is 0, 1, then its inverse will be reverse. The x and y become yx, right? So it will be 1 and 0. So therefore, it goes like this. So this point here will become this. And any point here will follow this mirror line. And this is 90-degree angle, right? And this point reflect over the mirror line here. So basically, this graph get close to the x-axis, but this graph will get close to the y-axis. And this is the graph of logarithmic function. Okay, so if we already know it's basic, and I will skip how to talk about domain and range of this graph because everybody know that. The domain, but let maybe just mention a little bit. Domain of this graph is on value of x, such that you see the x never approach to the 0, right? To the x0 here, right? It on this side, x start from 0 all the way up. So got it, x have to be bigger than 0, and x belong to real number. That's the domain. Range of this graph, we'll be talking about the y value. Now this function keep going and draw up like that, right? So the range, it will be, and it go from negative infinity. So on the y value, set that the y belong to the real number. No restriction. It's go from negative and go up this way, this way, this way, right? So the y is from negative infinity to positive infinity. So that's the range of this graph. And this is the log, right? The log graph. This is the exponential graph. Okay. So now let's say if I give you the question is say find the limit. Find limits. Okay. Let's say the first question is say limit of x. Sorry. Limit of ln of x plus 4. When x approach to minus 4 to the right hand side. So what is the ln? The ln is the same like log, right? However, the base of the log is base 10, right? For logarithmic, the log have a base 10. So anytime people write log of 5, it means the base is 10. But for log, because they don't want to, it's like lazy, right? Like you say 1x, but you don't write 1, you just write x. So the log the same, they don't write the base here, but its base is 10, right? But the ln, for the ln, it's the same like a log. However, its base is the e value, right? E to the y here. And the e value is the natural number in math. And that value is equal to 2.718, blah, 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 blah. So that is the base. So the base of log, instead of base 10 is e. Instead of con log, they should con the z ln. Okay? But the idea is exactly similar. It's just different, the base. This is, we call a natural number. And it, on your calculator, you can see there is an E letter there, and you key on and you see the value of E is 2.71 blah, 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 8 or whatever, okay? Now, let's say if we evaluate the limit of this ln, x plus 4. So how do we evaluate? Usually we plug in the number, right? And we know that the x plus 4 here, the condition here, have to be positive, bigger than 0, okay? So if you have a negative here, it won't work. That's the condition. So let's say, how do we find this? So the limit of this function when x approach to minus 4 on the positive side, it will become, if we plug in minus 4, and on the right hand side, right? Minus 4, and if it's on the right hand side, so you have minus 4. On the right hand side of minus 4 will be less than this value, so it's minus 3.999. adding with 4, right? So this is the same like you evaluate the limit when x approach to -4 on the right hand side. This value become ln of 0.001, right? And let's say you have a ln of this is very small number, and you key in the calculator, the result will be positive infinity, will become very big number when you take the ln of it. Okay, and actually so it will be negative infinity. So what if you find the limit of this function the same, ln x plus 4, but when x approach to positive infinity, what happened? Actually, if you want to wrap in this here, you can find it as well. The ln function x plus 4, this is the transformation of the asymptote, vertical asymptote here. Instead of at 0, we move to the left 4 unit. So 1, 2, 3, 4. So the asymptote, vertical asymptote, we move here. And the ln shape will become this function. So we can see that if x approach to positive infinity, the phone function ln y function will also approach to positive infinity. Okay, so I just want you to familiar a little bit with on the notation, the domain, the range, and how you look at the function, understand how the limit look like. Other than that, this calculus have a lot to do with derivative, which is derived from the limits, and you will see them in the next video lesson. So as after we finish the limit of trigonometric function, we haven't talked about that yet. The next video will be limits of trigonometric function, and these are just the basic idea, right? So I go through quicker and do not give you a lot of exercise and homework about this. But when we get into derivative derived from the limit, you will see the derivative. And for the derivative, we also have a lot of formula in the derivative, and we use them to evaluate the derivative, the rate of change of the function. And you apply the derivative, the rate of change in economic, in finance. For example, the buyer want to see, the seller want to see if one more unit of production make, what is the trend of the function? Do people will buy more or less? And if people buy less, then you shouldn't increase the production, right? It's for the manufacturing. So that's very useful, and it's applied in on the concept using the derivative. So I will end the video here, and stay tuned for my next video for the limit of trigonometric function. And I hope you enjoy my teaching online. Now, back on the time when I learned, we never have an internet like this. So I myself, before for learning, we very struggle because there no free lesson online video like right now. And if I have to have a tutor, it costs me like $160 an hour, you know. So, and I could not afford this time. So I'm very happy like right now in advance of technology help us to build our knowledge about math, which is the foundation of technology, but we use them backward and to support math, and math support them. So we support each other. So I hope that you enjoy the free learning online channel. And please, if you like my teaching, hit the subscribe and like button. Thank you. Bye for now.